Good afternoon, everyone. We are security research from Baidu Security X team. It's a great honor that our talk was selected by Black Hat USA. Today, Shupeng and me will present this talk because the COVID-19 we could not share it face-to-face with you in Vegas. Here is the agenda. First, we will introduce the background of the advertising industry. Then we will select 3 typical cases to deep analysis and underground industries. We will summarize the key technology and make a cloud analysis of them. Then we will introduce the project checklist to talk about how to solve those problems. First of all, let me introduce the advertising industry in general. According to the financial report of global internet companies in the past years, the scale of the global advertising industry has reached hundreds of billions of dollars. Actually, the advertising is the main business model for most of the internet companies. Typical internet models including social networks, search engine, app stores, short videos. So when an internet platform company grows up, they gather a large number of users and advertisers. The advertisers continuously to spend money on the internet platform company to promote the products. Then the internet company usually try to break the limitation that display advertise just only on their own media, such as the website, the apps. They start to open the advertiser library to the third party. That is the form of so-called advertising alliance platform. A large number of advertisers displaying advertisement on multiple third-party medias through the advertising alliance platform. For example, the advertiser invests $100. The advertising alliance platform company will get 30, and the third-party apps, applications get 70, form a three-way win-win situation. There are also many billing models, such as CPC is billing by click, CPM is billing by show count, advertising show count, CPA and CPI is billing by install or activation, not just by a simple click. Then I will explain where the advertising fraud occurs and the negligence. The most common advertising fraud occurs between the media and the advertising platform. The media wants to deceive the platform to obtain improper profit shares. We have selected 2 typical advertising fraud cases. I marked 1 and 0. I marked 1 and 2 in this page. Another type of advertising fraud is between advertisers. Generally speaking, an advertiser's budget is limited. If his budget is consumed by malicious click, his competitors can use a low cost to obtain more customers. We also select some typical cases in this scenario. I marked this as 3 in this page. Due to the time limit, the problems between the advertiser platform and other forms of fraud cannot be talked in detail one by one today. Next, my colleague Shupeng will talk about some typical cases about advertising fraud. Shupeng.
Yeah, hello everyone. Let's look at the first case. Generally, apps often integrate many SDKs for statistics, advertisement generation, message push, and so on. In the process of security analysis, we found some malicious behavior in one big data analysis SDK, and this SDK was merged into many well-known apps. As shown in the figure, this seemingly harmless SDK quietly and dynamically loads a DX malicious file. So it is that simple. So we have analyzed a lot of mobile phone malicious click cases, but this one is the most complex one we have met. First, malicious DX will request the latest patch. If the environment is safe, the cloud server will return patch.jar. And after a series of complex requests, the configuration file and the automatic click file are finally obtained. Yes, as shown in the figure. The SDK accesses several different servers and downloads a DEX file, 4JR files, and a JS file. So how does a malicious SDK realize automatic click? When the JR requests a cloud server just now, the target URL, keyword, click rate, and other task information have been downloaded to the app. The malicious JR starts an invisible web view, loads the target URL, and after a few seconds, injects auto-click script to operate the web page. In order to execute more Java functions in JS code, here, JS bridge technology is used. For example, first, we register a JS bridge named base in the SDK. Then, when we call base.getDeviceInfo method in JavaScript code, the same method will be executed in Java code. And how to start an invisible activity in the background? Activity container technology is used here. We need to implement our own window manager and view root MPL. We also need to hook some classes to let the activity run in our own container environment. Then the Android system cannot find such a window. And finally, this heading of web view activity is realized. So after analyzing the technology, let's take a look at the organizational structure of this case. The backdoor development company fostered by some channel numbers from advertisers. For example, AD channel equal ABCD in the URL. When users click on these advertisements, these channels will get a shell. Then they integrate backdoor code and the channel number into malicious JR file and sell them to the big data analysis company. And the analysis company merge them into their SDK. Finally, many well-known apps integrated this malicious SDK, but the developer didn't know it. So what about the PC side? We need to download some software, such as Office and WinRAR, when we go to some software download websites. On the download page, there are often local download and high-speed download buttons, and the high-speed download is recommended. When high-speed download is selected, it doesn't actually increase the speed. Instead, other software is bundled and installed, or even broader plugins are installed silently. While downloading and installing that target software, the downloader will judge whether there is antivirus software and then report to the cloud to obtain the task of silently installing softwares. At the same time, the downloader will also judge which browser is used by the system and copy the corresponding browser plugin CRX file to the corresponding path. Yes, it only needs to be copied and the user has no feeling. This is a new way of malware that we have found, so let's focus on it. This browser plugin includes the function of intercepting requests, modifying pages, and executing JS scripts. It can fully control the request and the response page. The background script will check whether the request URL is a target URL. The content script is used to inject code for different tasks. So let's take a look at the same example. When a user visits the video website, the script of the malicious browser plugin will first detect whether it's a high-quality user. Then it will send a JSON request to follow the target account, like the start of GitHub. Both the target account and the account number of follow are obtained from the cloud server. So there is no need to update the plugin and only need to return different tasks. Let's look at another way. If the plugin detects that the user is visiting an information website, such as some price comparison websites, the plugin will replace the channel number of the advertisements. So why does it do this? If the user finally buys the product, the replaced channel will get a share. That is, it can make a profit through malicious plugins. This is why the software websites prefer you to download with a downloader rather than directly. Let's take a look at the variety of malicious AD click tools. Easy programming language, or we call the E language, is a programming language that's used in Chinese and use Chinese as a development code. Because of the low learning threshold, E-language has become the preferred programming language for many underground industry groups. As shown in the figure, the programming code is written in Chinese. The development community of E-language is particularly active. In addition to communicating technical issues, it also supports the customization of special functions through payment, such as automatic click web crawler. So let me introduce some common tools of underground industry. Zheng web browser library is a web operation library included by default in E language. In addition to normal functions, it also supports browser parameter simulation functions, such as setting screen height, max touch points, and so on. This is an automatic dialog tool we obtained. It's developed in E language too. You can see the corresponding target URL and the other parameters to automatically talk with the customer service after clicking the advertisements. Why is there such a tool? Yes, it's used to attack competitors. Generally speaking, some high-value advertisements need to be displayed, clicked, and converted. For example, the payment, the download, and install an app on or the dialogue with the customer service can be judged as effective advertisements, and then the advertiser will pay for the money. This tool is designed to simulate this process and quickly exhaust the advertising budget of the competitors. In addition to the built-in library, Captain module is the most popular extension library. It uses the Chrome kernel. Through this module, developers can easily operate the browser to realize automatically modify date, simulate device fingerprints, inject security, and other operations. For example, simulate 5-point touch, which looks like a mobile phone device. In addition to AD cloud tools on the PC side, there are many similar tools on the mobile side. For example, the Flow Wizard app in the figure is mainly used to record input, sliding, clicking, and other behaviors, and then play them back when necessary. This kind of software is mostly used to improve our work and life efficiency, similar to the shortcut function in iPhone, but it's used by the underground industry. For example, they use recorded touch attentions to click on those advertisements. As we can see from the animation, this software completely replaced the recorded human sliding behavior. Compared with using JavaScript code to simulate the sliding from point A to point B, This sliding is more like a real person's behavior and is not easy to be detected by the risk control management system. Okay, now let's take a look at the core and the key technology analysis. Let's summarize the high-level underground industry group characteristics. Some of them have registered a large number of companies, and they claim to be advertising monetization platforms, SIP platforms, but in fact, they are companies engaged in the underground industry. Usually, they have huge profit scale. But the low-level underground industry group have the different characteristics. Most of them are individual or small team, small-scale group. They have low technical ability, but very diligent in order to make a profit. Although they often don't make much profit, they can also lead to massive damage and bad social impact. Now let's take a look at the technical details. The high-level underground industry group can generally control the user equipment remotely on a large scale, similar to the backdoor program installed on thousands of devices. For example, embed automatic click code in the app SDK or install browser plugins with malicious functions. And at the same time, a lot of simulation technology, hiding technology, and anti-detection technology are used. Compared with the high-level underground industry group, low-level uses various tools to realize the local simulation click function. Because they may not have high technology and channels to integrate malicious code into app, browser, and PC softwares. They can use a browser library that can be secondary developed, such as user agent simulation and hardware information simulation, or use a headless browser. And some IP proxy tools, touch record and reply tools are used to simulate clicking on this target. Okay.
Thanks, Shupeng. Let me talk about the new detection method we have proposed to follow the typical advertising fraud. First, let me introduce Hickless project. In recent years, the technical capability of the underground industry has significantly improved. We have seen a lot of tech leader of the underground industry company. They are used to work for giant of internet companies, and even some of them have security engineer backgrounds. We need to accurately separate the advertising fraud clicks to reduce the loss, and we need to continuously to trace them because they are tough because they are very tough to make a great profit. And because the technical background of my team are binary vulnerability research and web pen testing, this research work is suitable for us because it's the operating system, browsers, malware analysis knowledge. We are good at it. The Hickless project is consisted by a JS SDK and a malware host farm with a certain scale. Today, we will talk about 4 detection solutions that include headless browsers, invisible web view in mobile apps, and the mobile key press tools, and malware browser extensions. The first target, headless or automatic browser. Most of them are based on Chrome DevTools protocols. Typically, headless browser library, including Puppeteer, Playwright, Selenium, and just like the logo of the Puppeteer, there are strings connected to the Puppet. So we can control the browser behavior from that string. And those headless browser library off-shell support language are Node.js and Python. As Shupeng said earlier, most of the low-level underground industry, the education level, are high school, so they cannot write C++ program, and this script-based, such as Python and the JavaScript hacking tools is their favorite. There are some open source projects to detect headless browsers. As this table lists the features they choose are user agent, WebDriver, and is the console window opened or alert, or make alert to test. After test, we find that many detection methods are actually the difference between the Chrome and Chromium project, such as MIMO types and language. And some of them can be hidden through startup parameters such as WebDriver user agent. It can easily overread. And the left detection point seems not work for me. To solve this problem from the view of the security research, first we need to deeply understand the implementation of headless browser. By debugging the source code of the Chromium, we find that puppeteer start from Chrome through the command parameter remote debugging port equals 0. Then he get a port of WebSocket service, and then he can transmit control commands through this port to control the browser behavior and receive callback information generated by the browser. This is the Chrome DevTools protocol. And the headless browser is built based on Chrome DevTools protocol. So we think this transmit channel is the key detection point. In real scenarios, we are just the JavaScript and HTML that's running in the browser, so the permissions are limited. That means we cannot do much things. But inspired by the conception of the side channel, we can leak something by doing something to watch the time and energy consumed different. Let's look at the second picture first. There's a simple memory copy operation written in C++. It loops 10 times and copy a long data into a variable. It took 33 milliseconds in my desktop computer CPU. If we can force a memory copy operation through JavaScript, but this code is only executed when the browser has DevTools instance, we can detect whether we are in headless browser by the time delta. Yes, we have found a lot of detection entries, such as console profile, and which will traverse the DevTools instance, convert the parameter we passed in, and for the execution. Based on those ideas, we write a few lines of JavaScript code in the picture on the left. After test, this code can stable detect all headless browser, including mobile web view in apps, and it's harness for user experience because nothing is displayed on the Chrome UI. And if you learn this principle, it's easy to adopt this code to the latest browsers. And the Captain browser in E language is based on Chrome DevTools protocol. Yes, we can also detect it by this method. The next headless browser is Zheng web browser, which is based on Mini-Blink. Actually, the author of Mini-Blink is one of my friends. One day I asked him why this library is widely used by low-level underground industry. Do you have any detection ideas? Yes, he said. Yes. You can start from the advantage of Mini-Blink because it's very small and is developed based on a certain Chromium source code. So he cut off a lot of functions such as WebRTC. Yes, Mini-Blink does not support WebRTC. So you can do detection from this point. Let's talk about the next detection target, invisible mobile web advertisement click. We learned this through the report that disclosed by the mobile antivirus companies such as Qihoo, Kaspersky a few years ago. From the reports and communicate with an antivirus engineer, we learned that the analysis method is using static analysis and dynamic behavior sandbox. Those mobile antivirus companies generally only disclose those instances, but they do not disclose how to perceive it and detect it. So we just wonder, can we active perception such risks without the assistance of antivirus companies? This kind of malware, it loads malicious code dynamically from cloud, and it uses a highly customized web view and use JS bridge, inject JavaScript to web view. Because the container of the web view is invisible, the netizen do not know what is happening, but the mobile phone traffic is consumed fast, and the battery of the phone is drying fast. Here is a video. We can have a look how it's working. The left is a Pixel phone. The right is the web view instance open in the phone. The middle is HTML traffic. Let's have a look. We open a malicious apps. As you can see, the web view is. As you can see, after opening the apps, we are doing nothing. Yes, nothing is happened on the UI, but there are many hidden web views in the background doing bad things, such as show and click advertise. This kind of malware is scaled in antivirus, anti-debugging, and anti-VM use strong encryption channel for CNC. So far, the dynamic analysis, static analysis, and network behavior analysis is not so easy for us because it has any anti-technologies. And this type of malware, they display the advertisement through customized web view and use JavaScript, JS bridge on the Java side to cooperate with the code on the JS side, because this JS code, he knows the position of the AD slot, where is the AD slot, and then the Java code will use this position to simulate user behaviors, such as perform a click on the AD slot. We have several detection methods. Method one, we have a mobile. Actually, we have mobile app store products. That means we have a large number of app samples through a deeply customer developer room and customer developer hook plugins. We have bypassed all anti-analysis point, and based on this, we developed a set of host farm. Use a lot of phone to run all apps we have, to observe the dynamic loading of code, analysis the behavior of the web view. We find some underground industry by this farm is very effective. The second detection method is through JavaScript. By summarizing the key technology of the malware, there are JS bridge. They finding the location of the advertisement in the page and simulate the user behaviors. We can use JavaScript hook to watch, alert, promote, and other JS bridge communication variables, and to check is the landing page that muted by someone. Once the abnormal information is found, we can find a way to trace back to find the sample to complete the analysis. The next detection target are mobile key press tools and cloud phones. We have write a click script, run it twice. Yes, there is a milliseconds time difference between those two clicks. So we can detect the automatic click tools by coordinates of the click and rolling tracks. And on Android, we can also pay attention to touch event, motion event, such as touch, pressure, mobile phone touch range, and its the value is different with humans. As for the cloud phone, the software and the system usually cloned by a fixed hardware and ROM. If you find that a lot of same device accessing your devices from the same time, that's him. To detect the cloud phone, we should collect as many as web view features as possible, no matter how its user agent changed. But the web view feature remains stable because his operating system is not changed. The last detection target is malicious extension on PC side. Let's take a look at some public disclosed method for detection the extension in browsers. They are detect the resource used by the extensions and detect whether the ROM has been modified. For example, the picture on the right is a malicious extension. After it's run, it will create a mutex element. We can traverse the DOM through JavaScript to detect if it exists. Another detection method is by sending a message to extension to test if it exists. But I have never seen a malicious browser extensions that support message communication. So those methods does not work for me. The public disclosed methods all have limitations. So let's go back to the signature of the malicious browser extensions. The key features are they can interception request, they can redirect URL access, and inject JavaScript to web pages. As for URL redirection, we can guide the browser to access the URL we generated. We add a signature in the URL. On the server side, we can watch the request. If the URL parameters have changed, that means the browser has malware extension or driver. As for the JavaScript inject code, the way we percept is to use the CSP features. First, we made a web page that's with very strict CSP strategy, such as we refuse to load all cross-domain scripted. When the malware extension tries to insert JavaScript in the page, a validation will occur and report data to the server. On some special browsers, the log report of this validation will even include the name of browser extension. This is the key to trace the underground industry because my company has a large number of employees. As long as I know the name of the browser extension, I can find employees' computer infected with the malicious browser extensions. And then we can find the example and complete the analysis. Yes, it works great. The last
5 minutes, Mr. Shan Wang. 5 minutes, Mr. Shan Wang. 5 minutes.
Okay, I get it. And the last chapter is summary and recommendations. Now let me summarize this talk. First, I introduced the background of advertising industry, how the advertising alliance is formed, and where does the fraud occurs. Then I select 3 typical cases and analysis the underground industry chain structures, summarize the key technology and cloud chapters. Then we introduce how the project calculus solve those problems. We provide 4 solutions, and because of project calculus, hundreds of underground industry practitioners has been arrested by the police. They are sentenced for violating the criminal law. And the applicable law contains fraud, illegal control of computer information system, and destroy production and operation. And here are some advice for advertising industry. For the advertising alliance platform, we should share information with each other, as the underground industry often fraud on multiple platforms at the same time. For apps developers, we should carefully review the cooperation with the third-party SDKs. We should choose a big advertising alliance platform to monetize. For the browser developer, we should enhance the security check of the browser extension loaded by tempered configuration files. And because of the time limit and our poor English, we do not have a Q&A section today. If you have any question, please send it to this email, and I will reply you within 1 day. So this is all the content of our talk. Thank you for listening.